Welcome to the Explainer. You know, if you've ever found yourself totally battling rigid UI components, or maybe you've spent hours, like literally hours, hunting down memory leaks in complex forms, well, today's deep dive into B4XDaisyRadio is absolutely for you. We're going to explore how this component perfectly bridges that massive gap between sleek, modern front-end design and robust, crash-free back-end architecture. Just take a look at the sheer visual flexibility we're dealing with here. This custom component completely solves the rigidness you usually get with out-of-the-box radio buttons. You've got highly scalable grouped basics, dynamic sizes ranging all the way from extra small to extra large, and these incredibly vibrant Tailwind-inspired color variants, things like Accent and Success. I mean, it looks amazing, but how does it actually pull that off? Well, here's our roadmap for today. We'll quickly cover the ultimate radio button, then look at the anatomy of the component, dive into its smart sibling logic, check out sizing and theming, and finish up with shadows and custom states. All right, let's jump right into part 1, the ultimate radio button. To really grasp the flexibility of this component, we've got to define a core concept first, and that is the variant. Basically, a variant is how this component takes a semantic intent, words like neutral, primary, or accent, and maps it directly into beautiful theme-aware colors. So instead of hard-coding hex values every single time you need a specific button, you just assign a variant keyword. The component itself does all the heavy lifting, referencing active color tokens to make sure your UI stays perfectly consistent with your broader design system. And the best part? Zero extra code. Moving right along to part 2, anatomy of the component. Okay, so the absolute game changer here is the designer property. This is the crucial bridge that takes all that complex back-end logic and makes it fully configurable right inside your visual layout editor. You don't need to write a dozen lines of setup code anymore. You literally just click and select options from a dropdown, and boom, you're manipulating UI behavior instantly. And all of this power is exposed directly to you out of the box. You use group name to link your radios together so only one can be selected at a time. You can easily set the initial checked state and define those variants and sizes we talked about. You can even flip the label alignment from start to end or add some real depth with the shadow property. Oh, and for those tricky edge cases, you have total access to custom overrides for backgrounds, borders, and text. Which brings us to part 3, and honestly my favorite part, smart sibling logic. Look, we've all dealt with the nightmare of clumsy global registries or centralized managers trying to track radio states, right? It is literally a memory leak waiting to happen. But B4XDaisyRadio sidesteps that entire mess with an ingenious self-contained method called uncheck group siblings. It essentially manages its own state by dynamically traversing the view hierarchy. Let's break down exactly how it does this. The logic here is just remarkably elegant. When a radio is clicked, it first grabs its direct parent view. Then it sweeps through all the direct siblings in that same panel to uncheck any that share its group name. But step 3, that is where the real magic happens. It walks up the ancestor chain, meaning if you have radios buried inside complex nested layouts, it will still find matches in the outer layout. And finally, it safely exits if it hits the top of the hierarchy, absolutely guaranteeing it won't crash your app. And there's a great quote from the developer that hits the nail on the head regarding their core intent. By iterating parent-children instead of a global registry, the component avoids stale references entirely. This code-first approach is exactly what keeps your application incredibly stable, performant, and completely free of memory leaks. Let's move on to part 4, sizing and theming. This is where the raw math meets the visuals. Notice how every single aspect scales proportionally. If you pick extra small, the radio shrinks to exactly 16 DIP, the text drops to 10 points, and the padding tightens up to 2. But if you jump to extra large, the circle doubles in size, the font scales up, and the padding organically increases to match. It creates this perfectly calculated visual harmony, and the best part is you didn't have to manually code any of it. But what about those annoying edge cases with really long text strings? Well, the component actually acts like a little engine. It dynamically calculates the exact pixel dimensions it needs by rendering the string in a hidden canvas, measuring its precise width and height, and then adding that scaled padding we just looked at. It mathematically guarantees your UI is going to render flawlessly. No clipping, no weird cutoffs. And finally, part 5, shadows and custom states. Notice the fine details here when we compare these states. The label alignment flips seamlessly. The distinct disabled states automatically gray out options so users instantly know they can't be clicked. And my favorite touch, when you add shadows, ranging from none all the way to a massive 2XL drop shadow, it literally elevates the visual depth. It pops the active UI element right off the background. Now, for the true power users out there, you've got complete control using specific styling hooks. You can manually override the checked background, the border, or even the little dot color in the center. The component also handles nuanced visual feedback on its own. For example, if you set it to disabled, the code automatically drops the alpha transparency down to 0.2, so you get that perfect, professional disabled look without writing a single extra line of code. So to wrap up this explainer, I really want to leave you with a provocative thought. We've just seen a component that is engineered to be completely self-sufficient. It handles its own sibling logic, it computes exact dimensions using hidden canvas measurements, and it maps semantic themes directly to dynamic visuals. When a UI component is this autonomous, how might this code-first approach fundamentally change the way you architect your next cross-platform application? Something to think about. Thank you so much for joining me, and keep exploring.